Good evening, sir.
Yeah, good evening, Rohit. Good evening, Rohit. Just in 1 minute, we are starting with the class. 1 to 2 minutes, just let everyone join. So, Rohit, do you have any doubts from motion?
No, sir, no doubts. I've been able to solve all the questions. Sir, I had a doubt from chemistry.
Yeah, sure, you can ask that. Ask it, please.
Sir, how do we uh, know if a substance is physical or chemical? Like if its change is physical or chemical?
What happened?
Sir,
If you
how do we tell
Mhm.
what substance is physical and what substance is chemical?
What substance is physical, what substance is chemical?
Yes, sir, physical and chemical changes. It's related to
Okay, for
classification.
the changes, right?
Yes, sir.
Okay, you want fine. So, see what are physical changes and what are chemical changes.
So in physical changes, no new substance is formed. In chemical, new substances are formed.
Okay, so then you need to define what is a new substance, right?
Yes, sir.
So a new substance is a substance which has different properties. It has its properties different from those of the original substance, like the melting point, boiling point, all these they will be changed.
Yes, sir.
Okay. So this is now if even the chemical properties, its reactivity will change.
Yes,
Okay, so
sir.
if it happens, then it is a chemical change.
Okay, sir.
Okay.
So like the tearing of paper.
Yeah.
Okay, sir.
Got it now? You just
Yes,
need
sir.
to, okay. If you tear a paper, if you fold a paper and make a boat of it, so someone will say that you have made a new substance, but that is not a new substance.
Sir, we can get the paper back to its original properties.
Yeah, no, it has its properties as it is. The properties of
Yes,
paper
sir.
haven't changed. It's still paper. Okay.
Yes, sir. I got it. Thank you, sir. Sir, burning of paper will be a chemical change, no?
Yeah, burning of paper will be a chemical change.
Okay, sir. I got it. Thank you, sir.
Okay. So now I think we can start.
Sir, can you once more explain microscope and its functions, each part?
Which one?
Microscope.
Microscope, right?
Yes, sir.
Okay, see, microscope is not in detail in class 10th, but yes, a small part, microscope you are talking.
Sir, in the cell chapter, microscope.
In the cell chapter, okay, okay, compound microscope and simple microscope, right? I don't, I thought that how you got microscope in your syllabus. Okay. See, the microscopes, they are the lenses or they are the instruments which are used to magnify a substance. So first of all, you have a simple microscope. There are three types of microscopes which is generally used. You have a simple microscope, compound microscope, and an electron microscope. कम करो, कम करो, थ्री पे करो, थ्री पे. So the types of microscope. What does a simple microscope consist of? What does a compound microscope consist of?
Sir, I'm asking about compound microscope.
Yeah, just I'm explaining all. Then you have electron microscopes. So see, with the simple microscope, a simple microscope consists of just a single lens. There is a single lens which makes a simple microscope. So a single lens which we take as a single convex lens, which we also call as the magnifying glass. So I think everyone has used a magnifying glass. Yes, is there anyone who has used a magnifying glass? This is also called as a magnifying glass.
Yes, sir.
Okay. So this can magnify the image to us a few times, maybe 2 times, 3 times, 4 times, maybe 10 times. Okay, there are microscopes which can magnify it up to 10 times, 45 times. Okay, then after simple microscope, you have a compound microscope. So the compound microscope, it consists of two lenses. Okay, so in the compound microscope, you have here one lens and here another lens. It consists of two lenses. Now the first lens, suppose here you want to observe the bacteria that you want to observe, that you place here. So one of the lens which is placed near the object is called as the object lens. And the lens which is placed near the eye, we observe from here. So when we observe from here, this lens is closer to eye. We call this lens as the eye lens or eyepiece. This length of the microscope, this much, we call as the length of tube. Then there is a platform on which you can place the object to observe. This is our platform. And below this platform here, you have a small tiny pore or tiny hole is placed over here. Below this, you have a mirror over here placed. So light from here comes on this mirror. Mirror reflects it through this hole, and this light now passes through the object to the microscope. And hence we are able to observe the object. Got it? So compound microscope, it can magnify the object something about a 900 times or 1000 times. Generally, nearly about 1000 times can be magnified by a compound microscope. Then after that, you have an electron microscope. So electron microscope has the ability to observe it or magnify the objects to a very high extent. And this has the maximum magnification. So an electron microscope has the maximum magnification. Anything else? Yes, is there anything else that you want to know about these microscopes? Okay, now let's continue with force and laws of motion. So I think all of you are almost clear with the topic, force and laws of motion. Okay, but before moving on to the next chapter from physics, that is, before we move to the gravitation, I want to make sure that all of you are completely thorough with the chapter force and laws of motion. So we'll continue one of the assignments from the force and laws of motion. So just give me 1 minute. I'm just presenting the force and laws of motion with you all. Okay. So you can recall, is there anyone who is have, okay, just give me a quick brief about the chapter before I start with the question answers. So as a brief of the chapter, force and laws of motion, if you need, if I'm just placing the topics, I'll just telling them a little bit detail about it. If you face any problem or if you have doubt about the topic, you can ask. Okay. So this chapter is force and laws of motion. So force and laws of motion, first of all, we define what is force. Okay. So the type of force.
Sir, can you repeat the question? Hello, sir. Sir, what was your question? Oh,
Can anyone define force?
The
Sir,
force
it's
is a
the
push or
push
pull.
or a pull of an object.
Okay. It is a push or pull on an object. Right. So a force, it is defined as a push or pull
On
on
an
an.
object.
So on depending on the nature of the forces, we had also discussed different types of forces.
Sir,
But
balanced and unbalanced.
yeah. So we had force. It is
Sir, you didn't list down the effects of force, right?
I think everyone knows that. So we leave that.
Yes.
Okay, push or pull. That was just a quick revision required because actually that
Sir,
topic.
I have a doubt.
Yeah.
Sir, when a force is given, sir, can I show the diagram once?
Yeah. Sure. Show the
Sir, one
diagram.
second, I'm drawing it. Sir, can you see the diagram?
Yeah.
Sir, it's given 3 Newton and 5 Newton. So, for this question, do we have to use resultant force to find the
Yeah.
total force?
Yeah. Obviously, you will be using the resultant force.
Sir, so will the answer be 2 Newton because it's 5 minus 3? So,
Yeah.
F2 minus F1.
Yeah. Answer will be 2 Newton downward.
Okay, sir, I got it.
Yes.
So, if you are doing like that, you have to specify, if it's an unbalanced force, you have to specify the direction it's moving.
Sampath, can you be a little bit closer to
Sir,
mic?
in that resultant force, if it is 2 Newton, you have to say it is in downward direction or sidewards, like that, you have to
See the diagram or something like this. Just let me clarify once more. Okay, so this was the situation he drew. You have 3 Newton upward and you have 5 Newton downward, right? So the net force here, net force you get equals to 2 Newton downward. Now, what's your doubt here?
Sir, that was the question I had.
Yeah, someone, so I think Sampath was having doubt with this question only. Yeah, Sampath? Sampath?
Yes, sir.
Hmm. So what is your doubt?
Sir, it's clarified. Just wanted to ask that we have to specify the direction or not.
Direction has to be specified. See, force is a vector quantity, so you need to specify. If you are getting 2 Newton, so 2 Newton in which direction? In upward direction or downward direction? Towards the left direction or towards the right direction? In which direction you are getting those 2 Newton?
Sir, and also, if in a question they are asking to find a frictional force magnitude,
Hmm?
should we also include the negative sign or not, sir?
No, if they are asking the magnitude, then we will not include the negative sign.
Okay, sir.
Okay. So see, force, it is a push or pull on an object that we define the force. Then after studying this force, okay, we saw here force is a push or pull. Then it is a vector quantity. Force is a vector quantity. Then after force, we have started with inertia. So inertia, it is the tendency of an object to resist any change in its state of motion. So
Yes,
what
sir.
are the facts? What are the
Sir,
factors?
of rest,
Hmm,
inertia of motion,
hmm,
inertia of direction.
okay.
Sir, regarding inertia of rest,
Hmm,
an example will be when a moving bus suddenly brakes, the
hmm,
person sitting in the bus will fall backwards. This is because
The legs and the bus are in motion, but our upper part of the body is are at rest. The bus and the legs are in motion, and the upper part of the body is at rest. So when when the bus suddenly stops, we move backwards.
Okay. So instead of talking the upper part and lower part, just talk of the body. Okay, just say that the bus starts moving, whereas
And the body is at rest.
yes. Okay.
Sir, inertia of motion, we can take the same example, but we will fall. Inertia of motion, we can take same example, but we will fall forward because our body is in motion.
Okay. Now, what can we call here about amount of inertia? The physical quantity inertia. What are the factors on which inertia depends?
Sir, momentum.
No.
No, sorry, sir, mass.
So the factors on which inertia depends is mass. So sometimes this question is asked, and even the NCERT has a question based on it, that which object has a greater inertia.
Sir, I have a doubt. Sir,
Yeah.
for inertia of direction, sir, can you just explain inertia of direction to me once?
See,
I can't, sir, I can't relate the
inertia of
example to
direction.
you.
What happened?
Sir, I'm not able to relate the examples to it. I'm getting confused. Only in direction, inertia of direction.
Okay. See, for the inertia of direction, we can call it to be a bus taking a circular turn.
Yes, sir.
When a bus takes a circular turn and the luggage which is tied on it which is kept on the bus will fall in the outward direction, or you can say the passenger sitting in the bus will feel an outward force.
Yes, sir.
This is because the bus is turning and the passengers have a tendency to go straight.
Yes, sir.
As a result, they experience an outward force.
Okay, sir.
Anything else?
No, sir, I understood.
So inertia of rest, inertia we have understood. Everyone has understood inertia.
Yes,
Sampath,
sir.
Sampath, you are not responding. Harshit,
No, sir, I didn't call you.
okay. Harshit, have you understood all inertia?
Yes, sir.
Okay. Shravan,
Yes, sir.
what is inertia of direction?
The tendency of an object to rest is only change in its state of motion is called inertia.
Yeah, that is inertia. But what is inertia of direction?
So inertia of direction you didn't write, sir.
It you didn't write, right?
No,
Or I
sir.
did write.
No, sir, you
But
didn't write.
so I didn't write, but I think Rohit said something about inertia of direction, and he clarified his doubt also. So you have to be attentive, right? Jitendra, can you tell about the inertia of direction?
Yes, sir.
Yes, speak up.
Sir, the tendency of an object to move in a straight line.
Yeah, the tendency of an object to move in a straight line or to resist
And
any
resist all
line.
the external forces.
Yeah.
Resist the external forces.
Are you somewhere outside?
No, sir.
Okay, so the inertia of direction, the tendency of an object to resist any change in the state of direction or any change in its direction.
Yes, sir.
In its direction. Everyone be active. I can ask anyone.
Yes, sir.
Then, Yukta? Yukta?
Yes, sir. Yes, sir.
So Yukta, what do you mean by inertia of motion?
Sir, inertia of motion is basically like if an object is in a state of motion, then it tends to remain in the same state of motion.
Yeah, the tendency of an object to resist any change in its state of motion. Okay. So if an object is moving, it tends to remain in the state of motion only. So that we call as the inertia of motion. So here we have inertia of rest, inertia of direction, and inertia of motion. Factors on which inertia depends. So inertia depends on mass. Whenever we are discussing about inertia, inertia will depend on the mass of body. Then after inertia, we studied the Newton's first law of motion.
Yes, sir. Sir, an object will stay at rest unless an external force is applied on it. No, sir, sorry. A body will stay at rest unless some external force is directly applied on it.
Harshit, what is inertia of, or what is the Newton's first law of motion?
So Newton's first law of motion is about the law of inertia, which means the object opposes any change in its state of rest or of uniform motion in a straight line until and unless acted by an external unbalanced force.
Yes, sir.
Yes. So is there any other name for the Newton's first law of motion?
So law
Sir,
of
law of
inertia.
inertia.
Yes.
Inertia of motion, law of inertia, sir.
Yeah, the Newton's first law of motion is also called as inertia of motion. So Newton's first law of motion, it states that first law of motion, it states that every object continue to be in its state of rest or of uniform motion in a straight line. A straight line unless acted by an external unbalanced force.
Yes, sir.
So unless it is acted upon by an external unbalanced force, there will not be any change in its state of motion. So that means if it is in the state of rest, it tends to remain in the state of rest. If
Yes.
it is in the state of motion, so it tends to remain in the state of motion. Okay. Now I gave you some example here. Okay, let's see. Newton's first law of motion. So here you have a question. Let's answer this. And this question is somewhere in NCERT, but I don't know where. So here an object or a body moves with a constant speed of 10 meter per second when engine applies a force of 20 Newton on it.
Yes, sir, I got it.
Okay, so it's like this: a body of mass moves with mass 10
Sir,
kilogram. Yeah, moves with a constant speed of 10 meter per second when engine applies a force of 20 Newton on it. So what should be the force of friction? Okay. So Sharwan, just think of this question. Sharwan will answer me. Is there, if anyone else knows the answer, so that person can send a direct message to me.
sir, can I
Just
try answering it?
if you know, just send a direct message to me. Okay. So I want Sharwan to try it out. Sharwan,
Yes, sir. Okay,
yeah,
sir.
can
Let
you
me
answer
try.
this?
Okay, sir. So should we multiply it? Hello? So can you hear me?
Mhm. Yeah, you are audible.
So should we multiply it?
What number should be multiplied and on what basis? On what criteria you say that it should be multiplied?
Sir, could I try?
Yeah, just one. You have sent the answer. I'll just see it. Jitendra, can you answer?
Yes, sir.
Yeah, Jitendra.
Yes, sir.
Can you answer this?
Sir, is it 100 newtons?
100 Newton.
Sir, may I tell the answer, please?
Yes, Rohit.
Sir, the force is already given and also the mass and acceleration are given. Sir,
Okay.
since there is a force of friction,
Hmm.
the force of friction would be 0 newtons, right?
Okay. So see, this question is from the Newton's first law of motion.
Sir,
And
it's 0 newtons, right?
no, the answer is 20 Newton.
Oh, yeah, right, sir, my bad. Sir, because the force of sir, we do 20 plus 0, right?
No, it's not 20 plus 0. Just try to understand the situation and
Yes,
then
sir.
answer it. Okay.
Sir,
So
would
see,
it be due to the balancing of forces?
okay, what is the acceleration here?
Sir, is it due to the balance force?
No, what is the acceleration given here?
Sir, 10 meter per second.
No,
Zero.
Huh?
0. Very good.
Zero.
Sampath is correct. Here the acceleration is 0. Nowhere you find acceleration given here. Acceleration is 0. How can we say that acceleration is 0, Sampath?
Sir,
Sir, because the body is moving with constant speed, that is, we can say constant velocity,
Yeah,
then
it is
it
moving
will
with a
move.
constant speed. It's moving with a constant velocity. Okay. Since it moves with a constant velocity in a straight line, so obviously the acceleration has to be 0. Okay. So here the acceleration will be equal to 0, right? And if the acceleration is 0 and it says that here the acceleration is 0, that means I can say the net force should be 0 since it is moving with a constant speed. So its net force should be equal to 0. Okay. And it says that there is a force acting on this. The engine is applying a force of, the engine applies here a force of 20 Newton. Okay. And we want to find out the force of friction. So see, the force of friction, it is applied in a direction opposite to the direction of the motion. Okay, so here this is our applied force F, which is equal to 20 Newton. This is force of friction. And what should be the value of force of friction so that the net force on the object is zero? Because it can continue to move with a constant velocity only when any object can continue to move with a constant velocity only when the net force on it is zero. Okay, so the force of friction should also be equal to 20 Newton, and since the two forces they are acting in opposite directions, so their sum is equal to zero. Got it, everyone? Okay, everyone understood about the Newton's first law of motion? Now see, from the second law of motion, before the second law of motion, we studied about momentum. Okay, so what
Yes,
is momentum?
sir, it's the product of mass and velocity.
Okay, so it is the product of,
Mass and velocity.
okay,
Sir, its SI unit is kg meter per second.
okay, it is
Its
the product of
CGS,
mass and velocity.
yes,
Is
sir.
it a scalar quantity or a vector quantity?
Sir, scalar.
Momentum is a vector quantity. It's
Vector,
a
vector,
vector quantity.
vector quantity. Yes, sir.
Okay, and what is the direction of momentum?
Sir, 0.
No.
No,
Jitendra, what direction do we take for momentum?
Yes, sir.
Zero.
Yes, sir.
Yukta, what direction is taken for the momentum? Since it is a vector quantity, so it must have a direction. So what is the direction of this vector quantity?
So same direction as the velocity.
Yeah, the direction of momentum is the same as velocity. So direction of momentum, it is, or we write here that it act in the direction of velocity.
yes, sir.
Got it? Okay. What is the SI unit?
kg meter per second.
Kg meter per second.
Sir, CGS unit is grams centimeter per second.
Yes. So momentum, it is a vector quantity. We generally represent momentum by the symbol P,
P,
and we write P equals to mv.
mv.
Okay. The direction of momentum is taken in the
Is
direction of velocity.
direction of velocity.
Okay. The SI unit of momentum, SI
kg
unit of
meter per
momentum
second.
is kilogram
Meter per
meter
second.
per second.
Sir, and the CGS unit will be gram centimeter per
Either we
second.
write it as kg ms minus 1, or we write it like this, or we write it kg meter per second.
Yes, sir.
Got it? So this is our momentum. Let us do one question from momentum.
Sir,
And then
and one more point would be mass is directly proportional to velocity, right?
no, where is mass directly proportional to
No,
velocity?
no, one second. Sir,
Moment,
momentum is directly proportional to. Sir, what is momentum directly proportional to?
it is directly proportional to velocity.
Velocity. Oh, yes.
It is momentum is directly proportional to velocity, and it is also directly proportional to mass.
Okay, sir.
So let's try to do one question, and I want everyone's answer. Everyone's answer should
Yes,
be
sir.
there in your notebooks. So when I write the question, within 1 minute, your answer should be ready in your notebook. So be ready with your books and notebooks.
Sir, ready.
Okay. And also see, if now all your cameras are off. So now I will not inform anyone. If I call your name once, twice, and you don't respond, so that means you are somewhere, and just inform in the group then.
Sir,
Yes.
sir, due to the power cut, can I keep my camera off or else I'm leaving?
Yeah, if you are keeping your camera off, and if suppose I call your name, you do not respond, so I will just inform in the group. Okay, so just be
Okay.
active during the class. Whatever is being done during the class, respond to it quickly. Okay, so here I give a few questions, and your answers should be quick. Don't speak up your answers. Write in your notebook and message me as a direct message. If you are asked, then speak up. Okay. So here the question is, so what is the momentum of the ball? Find it out. Okay. So I think the question is ready. You can start giving me the answers.
Sir, I gave it to you.
Okay. Try the second one.
Okay, sir.
So I just check the answers. Okay, I got two answers. Fine. You can take a screenshot of both these questions.
Sir,
Yes.
do we take returning speed means final velocity, right?
Yeah, the returning speed will be the final velocity.
Okay, sir.
This, okay, I want answers from everyone. Yukta, have you given the answer? Yeah,
Yes, sir.
Yukta.
Just a second, sir. I'm the last calculation.
Okay, so now I'm just
Sir,
giving you the answer
yes.
for the first one. So for the first one, your momentum will be equal to, this was your question number one, and you have your question number two. So your answer for question number one is, okay. So for answer number one, our mass given here is 350 gram, and velocity with which it is moving is 90 km per hour. Okay, so just I need to use the SI system of units. In the SI system of units, my mass will be equal to 0.35 kilogram, 35 kilogram, and velocity will be equal to 90 kilometer per hour converted to meter per second. So 90 multiplied 5 by 18, this is equal to 25 meter per second. So now I obtain my momentum. So momentum P will be equal to 0.35, that is mass, times velocity. Mass is 0.35 multiplied with 25. So I get my answer this to be equal to 8.75 kilogram meter per second. So I hope everyone, okay, 8.75. Jitendra, you gave the answer 10,500. Oh, it seems to be incorrect then. Sarvan, the first one is 31.5. Sarvan, where did you go wrong, Sarvan?
Sir, I didn't do 19 to 5 by 18.
Okay, so just take care. You need to convert it into meter per second.
Meter per second.
Always take care of the SI system of units. Okay, so that is why it is always advisable to do the calculations in SI system of units.
Okay, sir.
So from next time, I hope, okay, you'll take care in the next question. Question number 2.
Sir, I got it.
Okay, so just 1 minute. I'm solving it out.
Sir, can you check my answer, please?
Okay, just your previous answer was correct. Okay, so this one you're getting 15.65. Okay,
Sir, is it right?
no,
Oh.
you need to check it once more.
Sir, but I used the change of momentum formula. P into M minus M. P is M into V minus U. I use that formula.
Okay, so see, for the answer number 2, we find here the change of momentum, and change of momentum is equal to final momentum minus initial momentum.
Yes, sir.
Okay, that is what is asked in that question. So change of momentum will be final momentum mv minus the initial momentum mv. Okay. Now see, if you read the question carefully, it says that initially the ball was going with a speed of 90 kilometer per hour towards the
Which is
bat.
25 meter per second.
Yeah, it's 25 meter per second towards the batsman. And then it
Sir,
reverses back.
120 kilometers per hour will be 20 by 3.
Yeah, so 120 kilometer per hour you need to convert, but that will be in opposite direction. Okay. So the situation is like this. You have this ball and the ball going in two directions. So here the ball is going towards the ball, and here towards the batsman, and here the ball is going away from the batsman. Okay. So see, in one dimension, there are only two directions which are possible. So here, the two directions, they are taken as a positive direction and a negative direction. The direction, if we consider the initial direction to be the positive direction, that means we are considering the direction towards the right to be the positive direction and the direction towards the left to be the negative direction.
One doubt.
Yes, what happened?
Sir, can force be negative?
What happened?
Sir, can force be negative?
Can we force the negative? Force
No,
the
sir,
negative?
can force be negative in any situation?
Yeah, force can be a negative. That is a direction only. When you are positive or negative for a vector quantity, the negative means a change of direction. So see, if we consider this right direction or the object moving towards the right side to be the positive and the object moving towards the left side as negative. So see, why do we consider these directions? If you ever observe a number line, Okay. So you have observed and you always make a number line something like this. So here you have the 0 and towards the right side and this is the left side. I think we measure towards the right side, we take the numbers to be positive. So we take here 1, 2, 3 and here we take -1, -2, -3. So you can either take this side also to be negative in physics, but generally what we take is this one. So we have taken this direction to be the positive. That means, yes,
Also, still, if we want, we can also take the other side as negative, right?
yeah, the answer is negative.
So, like in the other side, if we took as positive, can we take the other side as negative also?
Yeah. So if you take this direction to be the positive and this direction to be the negative, then you will get a positive answer.
Okay, sir.
Okay, see. So we take the initial momentum, we find out the initial momentum here. So initial momentum will be equal to mass multiply velocity. So it's 0.35 multiplied by 25 meter per second, which we obtained in the previous question only. So I'm not doing that conclusion part. You can multiply them and you get this answer as 8.75 kilogram meter per second. The second one, here the velocity is negative. It's moving in the negative direction. So here if I find out my final velocity, so final velocity will be given as mass multiply velocity. Mass is again 0.35, but the final velocity is given to us as 120 km per hour. So we need to convert 120 km per hour to meter per second. Okay. So see how we can convert this. We have 120 multiplied with 5 over 18. So we have 20 by 3. So that's 100 by 3 and 100 by 3 is 33.3. This is 33.3 kilogram, sorry, just meter per second. Multiply 0.35 with 33.3. So if you multiply them, you get the answer. Multiply 0.35 times 33.3. You get 11.65. But since here the velocity is negative, okay, here the velocity is occurring in negative direction, we take the velocity to be negative and we obtain the final momentum as negative. Okay. So now if I observe the change of momentum will be final momentum minus initial velocity. Okay, so the change of momentum. Harshit, now you can tell. Can you tell the change of momentum?
Sir, I didn't understand yet.
You didn't understand this.
Yes, sir, I'm not understanding this concept at all.
Okay, so you didn't ask also.
Sir, I asked already. You were telling, so I waited.
Okay. Yukta, did you understood this?
Yes, sir.
Yes or no?
Yes, sir.
Okay.
Sir,
Yes.
sir, I did 350 by 1000. I got some answer. I got a wrong answer.
So why you did 350 by 1000?
Sir, because it's given 35 grams, right? So I took 350 grams, right? So I did 350 by 1000. I cancelled the 0, then it became 35 by 100. I
Sir, is it
forgot to convert it to 0.35.
sir?
Yeah.
Sir, is the answer minus 20.4?
Yeah, the answer is minus 21 point something you are getting.
Sir, 21.
Yeah, 21, I think. 21.
Sir, I'm getting minus 20.4.
Minus 20.4.
Okay.
Okay. Okay. So see, those who have not understood, okay, suppose consider here an object which is moving in one dimension. That means it can either move towards the right or it can move towards the left. Okay. So we consider it to be similar to a number line, and hence if the object moves towards the right, we take it to be the positive direction. And if it moves towards the left, we call it as the negative direction. Got it? So in our question, initially the ball was moving towards the batsman. So suppose it's like this. You have a ball here and this is moving towards the batsman. And let's say at this point you have the batsman. So we observe that the ball is moving like this. It's moving towards towards the batsman. Okay. So according to this sign convention, we can take this direction of velocity to be the positive direction of velocity. And when the ball returns back, so the direction of motion has changed. Now the ball is going away from the batsman. Okay. So are the directions of motion same or different? Yes, are the directions of motion same or different?
Different, sir.
Different. Okay.
Because they're in opposite directions.
Yeah, these directions of motion, they are different and they are in opposite directions. So the direction of motion that occurs towards the right, that we take as the positive, and the motion that occurs towards the left, we take that to be negative. Got it? So let's take the velocity. Also, the direction of momentum is taken as the direction of velocity. The direction in which you have the velocity, that is the direction of momentum we take. So here, since it is here, it had the velocity given by, it had its velocity v, which was 90 kilometer per hour, and this 90 kilometer per hour is equal to, in terms of meter per second, this 90 kilometer per hour was equal to 25 meter per second. Yeah. Did you answer? Did you understand this now?
Yes, sir. Understood.
No, you
Yes.
understood. I think it was Harshit who had
Yes,
doubt.
sir.
Okay, so Harshit, now it's understood by you. Sharwan, are you there?
Sir, I'm there.
Okay. So see, we take the velocity to be plus 25 meter per second. Since this is occurring towards the right, it is going towards the right. So we take this velocity to be 25 meter per second. And here, it is going towards the opposite direction. It is going in negative direction. So I take this velocity v to be negative. So it is moving with a velocity of 120 kilometer per hour. And I know that 120 kilometer per hour will be equal to 120 multiply 5 by 18.
0.3.
So 3, this is 20. So you get, if you multiply, you get 100 by 3.
100 by 2.
And 100 by 3 is 33.3, right?
Yes,
So
sir.
now this velocity is towards is opposite direction. So we take this velocity to be negative. So this is negative 120. This is also negative. This is also negative, and we got the velocity to be negative 33.3 meter per second. So right here, this velocity v is
minus 33.3 meter per second.
yeah, it is minus 33.3 meter per second. Okay, and here it was moving with a speed of plus 25 meter per second. So now which of the two velocity will be considered as the initial velocity?
So can I say?
बाजार में नहीं है, नहीं तो क्लास में लोग नहीं है. अच्छा ठीक है, तो क्लास में नहीं. हाँ ठीक है. हाँ गाँव में भेजो, गाँव में रह देना वो टाइम से. अच्छा ठीक है, फिर पढ़ा के क्या करें. नेटवर्क से कट जा रहा, फोन आ रहा तो कट जा रहा नेटवर्क. अभी कभी बोले बात करना बात लेके okay, so here you have the two directions of velocity. The one of the velocity occurring towards the right side, the other velocity towards the left side. So which velocity will be taken as the initial and which one is the final? And why? Jitendra? Jitendra? Which velocity will be taken as initial and which one as final?
So 25 meter per second will be taken as initial and minus 33.3 will be taken as
Okay.
final.
Okay, very good. So our initial velocity is plus 25 meter per second and final velocity is minus 33.3 meter per second. So, and the mass of this ball is given as 350 gram. In SI, this is equal to 0.350 or 0.35 kilogram. Okay, so this is 0.35 kilogram, and now I can find my initial momentum. So if I need my initial momentum, Harshit, okay, I think Harshit is not there. Yukta, have you understood?
Yes, sir.
So how I will get the initial momentum?
Sir, by final momentum minus initial momentum, which is mv minus mu.
Okay, so what formula should I write here now?
The initial momentum equals to mass into the initial velocity, which is 8.75 kg meter per second.
Okay, so this we obtained by multiplying 0.35 with 25, and we got this answer as 8.75. This is the previous one which we saw. 8.75 kilogram meter per second. Now the final momentum. So the final momentum is given as mass multiplied by final velocity. Okay. So the mass is 0.35, multiply mass with final velocity, and final velocity is
Minus 33.
minus 33.3. So if I multiply, I'm getting here minus 11.8 What is the value do I get? If I multiply, I get minus 11.65. Or you can say minus 11.66. Then, if I want the change of momentum, so change of momentum will be written as final momentum minus the initial momentum. Jitendra,
So,
find the change of momentum.
so final momentum minus initial momentum.
Okay, so find it and tell the answer. Here, what is your final momentum?
So 11.66.
11
11.66.
Yeah, final momentum is minus 11.66, and you have to put a minus and then initial momentum. So initial momentum is 8.75. So minus and minus makes it plus. That means you have to add them,
So the
and it
answer
will
is
be
2.4.
negative of 20 point. What do you get the answer? Negative
4.
20.4. Okay, so it's negative 20.4 kilogram meter per second. Understood, everyone? How do you find out the change of momentum? Okay, in the similar way, I give you another question. Try to solve that question. A similar question, and I think now everyone will be able to solve it. Player had so the ball had a mass of 400 gram. Not 400. Let's take it 750 gram, and starts to move with a speed of of 54 kilometer per hour. Find the change of momentum. Okay, so is there anyone who got the answer for this? Rohit, did you get the answer? Rohit, did you get the answer?
Sir, solving. Sir, we take U as 0, right?
What do you think should U be?
0, sir, because it starts from rest.
Yeah, so U is 0.
Class and the answer.
Yeah, it starts from rest, so we take U as 0.
Sir, 1 minute.
Yukta, did you get the answer?
Sir,
Yes, sir, the
almost.
last
Yukta,
part.
what is the value? Okay, what is the initial momentum?
The initial momentum, sir, just a second, I'm solving that part.
Sir, I'm getting 40.5 kg meter per second.
Okay, Rohit, what did you get as the initial momentum?
0 minus 54, sir.
0.
Yeah, sir, you told you should be 0, right?
Yeah, so what is the initial momentum?
Sir, negative 54.
Negative
No,
54.
1 second, sir. 1 second, 1 second. 1 second, sir. Sir, 15. Negative 15.
The initial momentum?
No, sir, 0. And final momentum is negative 15.
Why do you take negative? Has it
Oh,
top?
sorry, sir. 15, 15, 15. I solved it. That's what I'm saying, sir.
So initial momentum is 0 and we obtain the final momentum by
As 15.
multiplying mass, that is 0.75,
5,
with velocity, which is 54 times 5 by 18.
15,
So
sir.
15, right? So you multiply 0.5 with 15.
Sir, it will be 0 only, right?
Which one will be 0?
1 second. Sir, I got 11.25 as final momentum. So it's negative 11.25.
Yeah, it's negative 11.25. This you get negative 11.25. Why do you get negative?
Sir, because when we do 0 minus negative 11.25.
So why do I get, why we have to make final minus initial?
Yes, sir. Plus 11.25.
So final momentum is 11.25.
So, yeah, yes, right.
Initial, oh sorry, bye all of
Yes, sir.
you, already up, I didn't see it. Okay, bye all of you. See you again.
Thank you, sir. Bye, sir.